So I want to thank you for the invitation to come and speak here today. I really appreciate this opportunity. I'm going to show you something that I'll tell you is definitely a work in progress. Okay, my name's Kruemcke, as you can see there. I am the product manager for HPC, ARM, and a few other things at SUSE. One of the things that we have been doing with HPC over the past several years is trying to see how we can deliver better value to our customers. To be honest, for a lot of operating system type approaches to HPC has really been, how cheap can you get it, right? That's been the focus. Can I do it cheap? And what's cheaper than free? Well, free is not necessarily always the right answer, because there are costs associated with that. And as pretty much everybody has seen, we've seen that traditional HPC is kind of expanded, and it's going down to smaller companies, smaller people are using it, so not everybody has the full set of resources that some of these institutions have. And in fact, even when I talked to some of the large HPC guys, I said, you know, you guys don't need us. You can do everything yourself. You have a lot of people to work on this. And one of the answers that came back was, well, yeah, I can do that. It doesn't necessarily mean I want to do that. And so what we've been looking at is how we can improve what we're delivering via SUSE Linux and some other things around it to really make it easier for more people to use HPC type techniques more broadly. The issues we see, I mean, I could have put this up for any IT kind of problem at all. It's really around, you know, how fast can I get something running? How can I do it simply, and how can I maintain it once it's there? The maintenance kind of came in quite a bit when we started getting some of these high impact, pervasive exposure, security exposures. We suddenly had people that were knocking on our doors that said, gee, you know, we've been doing self-maintenance, but we really would like some more help with this because it was simply too complex to deal with kind of on an individual basis. So these are kind of the areas that we're looking at, and how do we deliver a better solution to you. And we've done a lot of changes already. There are more changes coming in the future. Obviously, you know, we're a software company, so we have a lot of partnerships, pretty much every hardware vendor you can think of out there. I'll give you some specific examples of some that we work with. But we are an open source company, so we do deliver only open source. Things that are proprietary, we have mechanisms to deal with those, to be able to make those available to our customers. And to be honest, that's one of the areas that I'm focusing on right now, is to make it easier for customers using SUSE Linux to consume Mellanox MoFed, the NVIDIA CUDA drivers, those kinds of things that we can't include in our distribution because they violate the GPL if we did. So HPE, one of our biggest partners, and these are no particular order, but I'm going to talk about a few that we actually have some work going on. So SUSE's got a long history of working with HPE. What we've been doing kind of most recently is working on some things to expand beyond kind of the x86 market. So we've obviously, x86 is the strongest platform for high performance computing. But you know, there's another platform out there that's been trying to drive things, and that's ARM. So we have been working, I'll show you a chart later, we've been working on ARM a long time, and a lot of that work has been waiting for the right SoC and the right server to get to the market to actually meet the HPC needs, which, as probably all of you know, with the ThunderX2, we're actually starting to see that. So we were happy that the HP Apollo 70 was actually the first ARM server that received YES certification for SUSE, and we are currently working with both ARM and HPE on a project we call Catalyst UK. So this is 3 universities in the UK that have been provided with reasonably sized clusters of 64 Apollo 70 servers. They just received these servers right at the end of last year. Astra kind of consumed all of the resources around ThunderX2 and Apollo 70s. But once that was finished, as you guys saw probably at Supercomputing 18, these systems were shipped out there. So they're up and running now. They're starting to kind of feel out the issues, and we're working forwards on that. Now, CRAY is another partner that, one of my biggest challenges, I'll tell you right now, is that SUSE has been in HPC for a long time. A lot of people don't know it. And a lot of the things that we've done either don't have the SUSE badge on it, or it gets kind of hidden when you look at the top 500 list. But CRAY has been a longtime partner, both as providing the basis for CLE, but also we work with CRAY on environments where actually SUSE Linux is the named OS on top of that. So this is another big partnership with us. CRAY was actually very early on the ThunderX2 program, and in fact, we're using kind of pre-release versions of SUSE Linux to build some of their early systems. And you guys no doubt have seen these charts before. You know, the basic idea behind a lot of the interest in ARM is particularly in the memory capacity. Anything that uses a lot of memory bandwidth tends to perform fairly well on ThunderX2. Of course, we also have a lot more cores there in ThunderX2 than we have on some of the other platforms. So there's a number of areas where this is an attractive platform. But once again, like I said, x86 is really the name of the game. These are, these are some new initiatives that are out there running now. Intel, well, as I said, Intel is our #1 partner with this. So pretty much everything that we do around HPC is largely done on Intel. I'll give you an example here in another chart. Lenovo is another one of our partners that we work with. Lenovo has also been working to improve the overall manageability and usability of HPC environments. They, of course, have this. They have a tool or utility. I don't know exactly call it called LICO, and LICO is basically a set of tools that they're providing to help manage HPC environments. This actually played into some of the work that we're doing that I'll talk to you about in a moment, called the HPC Module. But this is an area where Lenovo is growing. One of the examples where we had a customer environment, the LRZ here, this was an environment that was going to use free Linux. They were going to use CentOS and deliver it that way. We talked to them and they found out some of the things that we actually deliver as supported features of SUSE Linux, and they said, it's worth it to me to go with a paid Linux solution. And I'll just throw one other thing in here around paid Linux. One of the things I did do earlier, well, I did last year, is I decreased the cost of it, but we also have an academic initiative. So if you're an academic institution that's interested in using SUSE Linux, contact me, talk to me. We can find you a price that's really, really affordable. Okay, we also work with other partners in the HPC environment. Bright Computing is one that we certainly work with. The Bright Cluster Manager is used by a lot of our customers. In particular, when I mentioned expanding the space of HPC down to, financial institutions have been using it, but into manufacturing institutions, for example, it's really worthwhile to have a commercial product to help manage those kinds of environment. So Bright Cluster Manager is well known, well used on a number of our different customers. So they're a great partner for us. NVIDIA, obviously you can't do anything without NVIDIA support. We have a good support program right now with NVIDIA, particularly on our x86 environment. This is one area, as I said before, I'm hoping to decrease the pain. Right now, if you want to use the CUDA drivers, you have to go out somewhere else and install those separately. You'll still have to do that, but we're going to make that process significantly easier. And that is also something that I want to do for the Mellanox MoFed drivers. We have the inbox drivers built into SLES, but a lot of you want to get the latest and greatest. So we're looking at ways to improve those things. Univa, another partner. Once again, commercial space, we see this fairly often. The bottom line is we partner with pretty much everybody that's out there. In fact, there's others that aren't in this list that we also partner with. Altair is another one, PBS Pro, very popular workload scheduler. They have a pro version, they have an open source version. We're making the open source version available and then helping them to be able to kind of reach out to more customers than they had in the past. All right, so let's talk about this. Why do you want to use why do you want to use a paid for Linux? Really, the number one is, we're an insurance company. That's what we're about. We're there if you have a problem. We work through, with the open source community to address the issue, either by developing a solution or working with the community to develop a solution that we can then bring to our product. So that's kind of number one. That's really what our business value is overall as a company. We're an open source company. Operating system, obviously a large complex or a large component of that. The thing that we kicked off about 2 years ago was how do we go from just providing a cheap OS? I mean, that's really what we did in 2016 and before we were a cheap OS. We started to include some popular software in our distribution, effectively making paid support for software like Slurm, for example, as part of our overall distribution. Now, this is the part that I'm a little challenged with, because the traditional way that people used to manage dependencies and things like that is also in the process of shifting with containerization and things like Singularity. And so one of the challenges I have is how far do I go down this path and how far do I go, maybe in a different direction. And so one of the reasons why I come to these kind of events is to hear from you guys, hear what you guys are using, so I get a better idea of how I can serve that market better. And while some of you may not be using SUSE today, my goal is to make it as easy as possible. So even if you don't use it, if you need to use it in the future at some point, we're going to be ready for you. I mentioned the pricing on the subscriptions. SUSE does our pricing for clusters a little different than some of the others. We basically have one price. So if you have 100 nodes, it's 100 node time one price. We don't care. We don't have a different charge for head nodes versus compute nodes versus development nodes, any of that stuff. We don't. We just have one price, period, which makes it a little bit easier to deal with. But at the same time, it did require that when I looked at how we were pricing our solutions, is how do I get to the right price point that fits a lot of customers? If you've got 3,000 nodes, a few dollars here or there starts to add up. So we did pretty aggressively price our product, and as I said, there are even more options available. We do have a big track record in HPC, and as I said before, this is one of my challenges. Coming from a German company, German companies don't like to blow their own horn too much, so I have a lot of people that don't understand that we've actually been in the market and continue to have a pretty good support in the market. A little hard to pin down because not everybody publishes in their top 500 what Linux they're on, but we've done some analysis and we think that about 50% of the top 100 are running us, and I'll show you a chart later on. We think we're quite clearly in the lead as far as paid Linuxes overall. All right, so let's talk about the solution. So obviously the operating system is kind of the key thing you would think about. Yeah, you have an OS, great. Okay, the thing that we added to it about 2 years ago is something we call the HPC Module. Now, don't be kind of confused by the name. Module is a word that we use for something that we can update more frequently. So an operating system, once a year we're going to crank out a new service pack, and it's going to have a lot of new stuff in it, a lot of new patches, maybe a new kernel. We do a new kernel about every 2 or 3 service packs. But the HPC software stack is evolving really, really rapidly. Right? And so what we have done is taken a number of things, and I'll show you a list in a moment, of things that we have taken, we've taken in-house, we've built, we've compiled, we've packaged, and we actually provide support for, just like it was any other open software package. And part of the inspiration for this is OpenHPC, of which we're a charter member for OpenHPC, but it's not really kind of limited to that. And nor is it inclusive. I can't do everything in OpenHPC. There's simply too many things out there. But we have started to work through some of these packages, and I'm sure you'll be familiar with them. Now, not everything that's out there that people want to use in an HPC environment or any environment is something that I can bring into my product. And one of the classic examples is Singularity. When I started looking at this, a few years ago, Singularity was really starting to get a lot of traction, but it was really, really evolving quickly. And we said, we want to make it available to our customers, but we can't really include it in our distribution at this point. And so what we did is we put it in a PackageHub, and I'll talk more about PackageHub in a moment, but effectively it's a way for us to have very easy access to pre-built executables that we've done the building for. We've done some due diligence over to make sure there's nothing fishy there, and to make it really well integrated with our installation methodology. So PackageHub is basically a way that we can extend beyond just the supported stuff that we include. Now, some of you are probably familiar with OpenSUSE Leap. OpenSUSE Leap is kind of really kind of a progenitor to SUSE Linux Enterprise. So OpenSUSE Leap over the past couple of years has been changed how we package it, how we maintain it, and basically it is it's virtually a free copy of what we sell as SUSE Linux Enterprise with, of course, no support. The reason why that's kind of been important to us is that we had a lot of divergence between Leap and what the SLES package looked like, which meant conversion was a pain. We've kind of torn that down, and particularly for SUSE Linux Enterprise 15, Leap and SLES actually have the same version number, so it's a lot easier to tell where you are and where you're going. We do have Tumbleweed, which is a distribution that is the latest, greatest, hot and steaming bits. But most customers, that are going to use a free Linux, we would prefer that they would go with OpenSUSE Leap since it's a bit more stable there. We do have free developer subscriptions. What's kind of noteworthy about that is it's not just for x86, we also do that for ARM. So if you want to try out some of the ARM distributions, maybe you've got a spare Raspberry Pi around, you can try our ARM distributions on the Raspberry Pi. And you laugh a little bit, but that's actually one of my biggest businesses right now is people running SUSE Linux Enterprise on a Raspberry Pi because they're so blasted cheap. And you can spread 1,000 of them in a warehouse to monitor things. We do have enablement for Azure and AWS Cloud. In fact, we have a number of customers that are using both of those, primarily for cloud overflow, but there are some that are doing primary support out there. We'll support either, you can get your subscriptions from the vendor, or you can bring your own subscription to it. We work either way, and in fact, we're looking to expand that. I've got some other guys, particularly in the ARM space, that I'm hoping to expand the SUSE coverage for, because some people just want to try stuff out, and the ability to put a cluster together, in a cloud is a nice way to try those out. We have some other products that I'll talk about a little bit later, but it's not just the operating system, but it's it's some other things around that, and that's a space we're also looking to expand. Just to recap our support for ARM, so like I said, we really got into the ARM business early. Our first commercial release was back in 2016, and that was with the original Cavium ThunderX, if you remember that. Still out there, there's still a few of them out there. And we started enabling not only the operating system, but also our enterprise storage that I'll talk about more in a moment. That's our SUSE Enterprise Storage. It's our Ceph-based software-defined storage solution. We actually have customers using that in HPC environments, not as primary storage, but as an archival mechanism for the large amounts of storage are out there. And then you see a number of updates here on the SLES HPC module, and so we do that for 12 and 15. So at this point, we've shipped 4 releases now on ARM. So for us, ARM is just another platform. What's been kind of lagging, as I said, has been really trying to get those HPC-capable systems up there. We had hoped that ThunderX would do that. Well, it wasn't quite there. ThunderX2 certainly is there. We'd like to see some other vendors out there. In fact, we are getting more additional vendors into that space, but maybe not ones that are relevant to this audience because they're from Chinese companies. Okay, let's talk about the offerings a bit. We do support x86 and ARM, and if you ask me why I don't support Power, there wasn't a lot of focus on HPC at Power other than Summit. So IBM doesn't participate in the Open HPC project, so we really said we didn't see a lot of value in going there at this point. We'll see if that changes. One of the things that is typically important for customers that are doing HPC environments is once you've laid down a cluster, you really don't want to mess with it for a while. You want to put it down and maybe leave it static. You've got an air gap from the world, so you're not as concerned about security exposures. And so one of the things we did was provide an option for customers to stay on a given service pack of SUSE Linux for a longer period of time. That's through something called the wonderful name of Extended Service Pack Overlap Support. I did not name that. I inherited that from somewhere else, so don't blame me for that. Along the same lines, we also have a long-term service pack. So if somebody wants to get on and stay on even longer, and I'll show you a diagram that addresses that. One of the other things we did here is you'll notice we had support for smaller cluster sizes. So moving as we look towards more commercial use of things, I'm getting people that want to build, as low as 4-node, 8-node clusters just to get started. And we had a really high bar of like 64-node clusters was the minimum size to get it. We said, no, that's silly. So we have much smaller cluster sizes. And in fact, my engineering team is working on some tool that I hope to talk about soon to actually help customers who are not used to kind of large HPC environments roll out smaller clusters. So 10 to 12 node clusters, we see those in universities fairly often. We want to provide some additional tooling around that. One of the other things that we did as part of this focus on HPC differentiated is that we actually split off our HPC product from normal SUSE Linux Enterprise. One of the things that we wanted to do here was provide us with the flexibility that if we want to do different kernel tuning, some deep down stuff inside the operating system itself that maybe would not work in a general purpose environment, this gives us the flexibility to do that. We've made some little tweaks so far in SUSE Linux Enterprise HPC 15, but there's an opportunity to do a lot more there. And particularly as we get into these environments where we have heterogeneous environments, not only with GPUs, but also mixtures of x86 ARM, AMD, a whole bunch of different different architectures in there. There's a need for us to be able to deliver more kind of targeted acceleration for those platforms. So I'm not there yet, but that's certainly one of the areas that we want to go to. All right, let's talk about the HPC module. So as I said before, this is actually part of the product. It just has a different name so we can ship it more frequently. You see some of the things up there. I'll give you a longer list that's in a moment, but kind of the key one, obviously one of the big ones out here is Slurm. There are a lot of customers out there that are using Slurm and wanted to have a level of support. So we work with the community. And in fact, we're looking at ways to expand some of those relationships because they're, obviously, there are people that make their living off of this. So we need to be able to kind of coexist in the environment. We do this as x86 and ARM. We try to get I'm shooting to update this about 4 times a year. I'm not staffed for that yet. I'm getting about 2 times a year at this point. But it's an area we want to continue to grow in. And we do it both for SLES 12, our older release. Anybody that's doing anything new, we'd strongly recommend they go with 15, just for general purpose reasons. These are some of the software you can see in here, and I'll just pick on Slurm since it's down here at the bottom where I can reach. You'll see that over the releases we've done update releases to it. In fact, we've got another release coming up for Slurm here pretty soon. So some releases we add new packages, others we update them. The list gets longer. I'm kind of limited by engineering and test resources, but we select this, number one is we look at what people were using, but we also, in some cases, kind of respond to what customer needs were. So we had, particularly for the LRZ account, they had a dependency on Isinga 2, so we didn't really want to put it in there, but we put it in there and made it available for them. So this is something that we expand on, and I'm always looking for kind of insight into which things we should include in here. So we started out primarily with tools and then started adding libraries. And so that's kind of an expanding level. And that's where I get into that discussion about, well, how much are the library dependencies inside the OS as useful as putting them inside of a container environment. To install it, this is just threw the slide in just. So one of the things that we did with SLES 15, SUSE Linux Enterprise 15, is that we took the module approach to the extreme. So we now have one installer for SLES. If you install, you go in and you say, what do I want to install? Do I want to pick HPC or do I want to pick regular SLES or SLES for SAP? Doesn't matter, it's one install media. And then once it installs it, assuming you pick a pre-configured template, it'll install a bunch of packages with it. If you don't pick any template, it'll put a very minimal system down there. So it's a little bit different than what we've done kind of traditionally, where SLES 12 was this big mass of a whole bunch of packages, and then people would spend all their time picking it apart. We took the opposite approach for SLES 15 and said, let's start small and work out from there. And that was kind of interesting, the discussion earlier about memory size, memory size compared to core count, and that the overall amount of memory that's available in some of these systems, per the number of cores has actually gone down. So this is something we've had response to. We also have a micro OS that we use with our container offerings. That's not part of my HPC offerings at this point, but that's obviously a direction we'll go, because we do have customers that are using that more for DevOps type work, and it's a micro OS with containers and Kubernetes on top of it to drive it. That's in our commercial space. I'll get something like that for HPC in the future. Okay, PackageHub, I mentioned this earlier. Kind of the key benefit here for customers is easy access to code that we don't support. So when you install SUSE Linux Enterprise, it's very easy for you to install new packages. The zipper command is our kind of traditional command for doing it from the command line. What we realized several years ago was that some people said, hey, I came from OpenSUSE and I had all these packages, because OpenSUSE's got, 5 gazillion packages available. I want to use some of those inside my commercial SUSE Linux Enterprise environment. So we came up with this concept called PackageHub. We curate them, we build them, we run some QA on them, provide them out there. They're unsupported, but obviously we do take input through the community, so they're community supported, and no additional charge. A couple of the ones here specifically that we did around HPC was Cluster Shell and Robinhood. We had some customers that wanted those utilities, and we really didn't see the need to put them into regular SLES immediately. I mentioned Singularity was one that we put in there, and in fact right now we're trying to get to the point to update it to Singularity 3.1 or 3.01. The transition to Go for Singularity was a bit of a surprise to us, but okay. TensorFlow, we've got that, and Caffe too. So we're also working on building out some of the AI frameworks out there for people to use in machine learning. So anyway, PackageHub, so, it's an integral part of what we provide. It is, it's a way to get easy access to the software that we don't yet support. All right, this is an ugly hard chart, but I put it in here just for reference. This kind of shows how we actually do releases. We have 2 releases in the market today. We have SLES 12 and SLES 15, or SLE HPC 15, SLE HPC, anyway. So SLES 12 has been in the market now for quite a while. It's currently at Service Pack 4 we just released. Service Pack 5 is planned to be the last Service Pack for SLES 12. It'll be coming out generally towards the second half of the year. SLES 15, which is our newest release, basically comes out in the middle of the year. So we had the initial release, SLES 15 last year, and then we're working on SP1. Now, one of the things that we do that's different than some of the other distros is we actually changed kernel releases. So if you look up at SLES 12, it originally started out on a 3.8 kernel. For Service Pack 2, we moved to the 4.4 kernel. ARM was actually a driver for that. We really needed to get to the 4.4 kernel. And then for Service Pack 4, it inherited the kernel that we put into SLES 15, which was 4.12. So generally about every 2 service packs or so, we'll upgrade the kernel release, but there are lots and lots. There's thousands of backports that we do in between these, so it's almost kind of nonsensical to look at it as a 4.12 kernel when it's got all this other stuff on it. A normal service life, as you can see here, is about a year and a half. So from the start of the release until it starts to go in kind of the mode where we're waiting for you to transition to the next one is about 1 year, and we have what we call a normal service pack overlap. So in this example, when Service Pack 1 comes out, you're going to have 6 months here to make a transition. This funnily named SPOS thing basically gives you the option to stay on that service pack for an additional year for about 20% of your initial cost. So in other words, for 20% more, you can get that full additional year. After that, you can get long-term service pack support for 2 more years beyond that. This is something that I'm evolving to, so as I see customer demand for this, I'll move to longer and longer years of support. I understand for, if you're rolling out a large HPC environment, roiling it every year or every year and a half is still kind of mighty fast. But that's something that we're trying to evolve to. You also see the little kind of Pac-Man things there, and that's where we intend to drop new updates to the HPC module. So that's more of a continuous process, really driven by engineering and QA. We have some other products that are relevant to HPC. The first, I'll kind of start backwards here. SUSE OpenStack Cloud is our rendition of OpenStack. We've had this in the market, I think, since the G release. It's been in the market a long time. We incorporated HP Helion into this. There was a merger, or our parent company at the time, Micro Focus, had purchased SUSE, or had purchased HP software assets, and so we brought Helion over, merged it into our OpenStack Cloud offering, so that's available as well. SUSE Manager, which is used for doing updates and making sure that your systems are patched. That is not as relevant to the big guys like you, but for our smaller customers, they really like being able to do that because it gives them the assurance that the systems are patched at the right level. SUSE Enterprise Storage is our Ceph-based software-defined storage product. So I showed you earlier that we supported this a couple of years ago, first on x86. Then we came out in early 2017 with the release for ARM. We actually do have customers that are using SUSE Enterprise Storage in HPC environments as archive, giving them a way to archive things. What's different about our SUSE Enterprise, there are a couple of things that are different about our Ceph implementation. First is we put a very easy to use interface on the front of it from something called OpenATtic. So it's a real nicely easy to use, not a command line type tool. The other thing that's really nice about our SUSE Enterprise Storage is that we do not charge for capacity. We only charge for servers. So you build a server environment up. I think the minimal size is generally about 7 nodes. Once you go beyond that, you can add more capacity just by adding more servers. We'll charge you for the additional servers, but you can have 1 disk in there or 24 disks. We don't care. So SUSE Enterprise Storage out there, we have been working specifically on some of these things to make it more attractive to our HPC environments. Obviously, it's not fast enough at this point for direct storage, but it is certainly good for archive, and we do have customers doing that. This is just a view that one of my colleagues took a look at on paid Linux overall in top 500. And you can see kind of where we think that SUSE lines up. Now, a lot of that is through CRAY and CLE, but we have a pretty substantial share there. Red Hat did jump up, by the way. I haven't had this replaced since Summit, so Red Hat did jump up a couple of points based on Summit itself. So there's definitely a good representation there. So, overall, what we think is we've got a product here that we're evolving to better fit the needs of HPC customers. I think we've got a price point that for a lot of customers is quite acceptable. Once again, if you are an academic environment and you want to know more about academic pricing, come talk to me. The prices can be really, really inexpensive. We do have this HPC module, and this is something, as I said, we're growing. We're adding additional libraries, additional packages to it. But as the market changes to more container-based things, I think we'll have to adapt this to fit that environment. x86 and ARM. So if you run around x86, AMD, or ARM-based systems, we've got them out there. We're supporting across all of them. All right. Thank you very much. Questions?